Now that we have defined the semantics for propositional logic, we can construct a knowledge base for the Wumpus world. We focus first on the immutable aspects of the Wumpus world, which are not changeable. So for now, we need a few symbols like pxy is true if there is a pit in xy. Okay, so pxy is true if there is a pit in xy. Let's say pxy means is is true if there is a pit in xy, something like that. Or we can just write pxy. That means it is true. Similarly, okay, or bxy to say breeze in xy. The sentence we will write we will write suffix to derive not p12. So what we want to derive, that there is no pit in 1 2. So we want to derive, let's say derive not p12. That means there is no pit in 1 2. That's our objective. Okay, that's using different inference rules and other thing, we will derive that. So we will use all the knowledge we have, okay, percepts, the game rules and all this. So we level each sentence using R1, R2, something like RI, so that we can refer to them. So the first one, from the rule of the game, we know that there is no pit in 1 1. Okay, so we know that there is no pit in 1 1. So let's kind of continue with that. Let's say R1 is basically no pit in 1 1. Okay, so from the knowledge of the game, we know that if there is a square is breezy if and only if there is a pit in a neighboring square, neighboring which is adjacent but not diagonally adjacent. This has to be stated for each square. Okay, so this is true for the entire game. For now, we include just the relevant square. Okay, so for when we start, our relevant square is just the first one, 1 1, 2 1. Okay, because the agent is facing in the front, so it will go in the front, we are assuming. So here we say, so that we earlier said that 2 1 and 1 2 are the squares to go. So first let's say that the rule 2 is basically B11 biconditional P12 or P21. Okay, so that means there is a breeze in 1 1 if there is pit in 1 2 or 2 1 or both, and other way around. If there is a pit in 1 2 or 2 1, then there will be breeze in 1 1. Okay, then similarly we can also write another rule which is R3, which is basically saying that B21, that means there will be breeze in 2 1 by conditional P11 or P22 or P31. Okay, or P31. So if there is a breeze in 2 1, which is this cell, then there is either a pit here or here or here. So that's exactly that means. Okay, so these are the by the definition or the rules of the game. Now the preceding sentences are true in all Wumpus worlds. Okay, so this R2 and R3 are true in all Wumpus world, not just for this. Any cell, if there is a pit nearby, there will be breezy. Now we include the breeze percepts. Okay, now we know the percept, like this percept, when we went to move, we got that percept. So I will write it here saying that R4 is basically not B11. Okay, not B11. So we said that the percept we did not really have any percept when we went to 2 1, right? No, we have the percept of breeze. Okay, so but cell 1 1 had no percept, so that means this is basically means not B1 1, so R4. Now when we move to cell R5, so the next cell 2 1, we had a percept which says R5 said B 2 1. There was breeze in 2 1. Okay, so 2 1 had breeze, right? We know that. So now we need to, our goal is to decide whether KB entails alpha, like not P12, which is something we wanted to prove here. You remember derive, is it entailed by our knowledge base? At this stage, our knowledge base has this sentences R1, R2, R3, R4, and R5. From these 5 sentences, can we derive not P12? That's what we are trying to do. So models are assigned true or false to every propositional symbol. Okay, we know that. So that means we have so many propositional symbol. We can do one model checking where we assign true, false, and all combinations of true, false to all these variables. So what are the variables we have? B11, B21, P11, P12, P21, P22, and P31. So there are total 7 variables. Okay, 7 variables, and there can be total 2 to the power 7, like 128 possible models. And in only 3 of this, the knowledge base is true. We have already shown earlier that the knowledge base is true only in 3 of them, right? We have shown that before, that knowledge base is true in only 3 of them. So here, so 7 variables, you can see that P11, P12, P21, 3 variables, and then P22, 4, 3, 5, B21, 6, B11, 7, and then 7, yeah, 2 to the power 7 possibilities, right? So model checking will check all of them and try to find out if P2, not P12 is true, whether hence there is no pit or not. On the other hand, we want to, apply something more useful or less costly. Okay, model checking is expensive. We have already said in the previous one where we have to explore all of them, all possible combinations, and decide which one is more useful. So we will continue using the theorem proving approach. Okay, using the theorem proving approach when we are trying to use different inference rules to show whether from this rules which are in the knowledge base. So knowledge base has all these rules, right? Knowledge base now kind of contains R1 through R1 through R5. Okay, R1 through R5. So we'll continue this discussion